So hopefully you've got these formulas, these identities handy, because we definitely need to know them. The first thing that you're going to do is you're going to write down the formula. So write down the formula before you use it. Writing down the formula is going to help you learn it and memorize it. So we're dealing with a cosine function of a difference. So I come up to my formulas because I haven't got them memorized yet, and I'm going to use the cosine of u minus v. I'm subtracting two angles inside the parentheses. And I'm going to write down that formula. That's the cosine of u times the cosine of v plus the sine of u times the sine of v. Now here, u is equal to 2 pi over 3, and v is equal to pi over 6. So we're going to sub these values in, sub into the formula. So we've got the cosine of 2 pi over 3 times the cosine of pi over 6 plus the sine of 2 pi over 3 times the sine of pi over 6. The cosine of 2 pi over 3, 2 pi over 3 is an ordered pair of negative 1/2, comma, square root of 3 over 2. So the cosine is going to be negative 1/2. The cosine of pi over 6, the ordered pair for pi over 6, is the square root of 3 over 2, comma, 1/2. Cosine is going to be square root of 3 over 2. Then we're going to add to that the sine of 2 pi over 3, and the sine of 2 pi over 3 is the square root of 3 over 2, times the sine of pi over 6, and the sine of pi over 6 is 1/2. So this is a very interesting one. We've got negative square root of 3 over 4 when I multiply those two fractions straight across, plus the square root of 3 over 4. These are additive inverses, so when we add a number and its additive inverse, we get 0. Now the only way cosine is going to be equal to 0, the cosine of an angle is going to equal 0 when the x value is 0. So when I subtract 2 pi over 3 minus pi over 6, I must be getting pi over 2. So let's think about that. 2 pi over 3 is right here. Pi over 6 is the same thing as 30 degrees. So 2 pi over 3 is 30 degrees away from the y-axis. So when I subtract, and let me show you with fractions, 2 pi over 3 minus pi over 6, multiply by 2, multiply by 2, we get 4 pi over 6 minus pi over 6 is 3 pi over 6, which is indeed pi over 2. So it makes sense, the cosine of pi over 2. And you might be saying, well, why did we just go through all that then? If we could have just easily done 2 pi over 3 minus pi over 6 to get pi over 2, why did we have to go through this formula? Well, because in some cases, it doesn't work out that nicely. So sometimes we have to know the formula, and I'll show you in another example where that comes into play. But right now, I just want to make sure that you know how to sub into the formula and then simplify. So sub and simplify. So we're going to try this one more time, and then I'm going to show you where you really do need to know this. The tangent of pi over 6 plus 2 pi over 3. Well, I'm kind of getting the hang of this. I already know exactly where that angle is if I add those two fractions together, so I have an idea in my mind what the answer should be, but we're going to play the game. I'm going to write down the formula. The tangent of the sum of two angles, so that would be u plus v. So that's going to be the tangent of u plus the tangent of v over 1 minus the tangent of u times the tangent of v. And u and v, u is pi over 6 and v is 2 pi over 3. So we've got the tangent of pi over 6 plus the tangent of 2 pi over 3 all over 1 minus the tangent of pi over 6 times the tangent of 2 pi over 3. The tangent of 2 pi over 6, the tangent of pi over 6, well, pi over 6 has an ordered pair of square root of 3 over 2 comma 1/2. And the tangent is y over x, so that's going to be 1 over the square root of 3. Plus the tangent of 2 pi over 3, and that's negative 1/2 square root of 3 over 2. So that's going to be plus negative square root of 3. And we can put that over 1, just so that we have two fractions. And then in the bottom, we're going to have 1. I should use another highlighter here just so you know where these numbers are coming from. So that's where those two numbers came from. Then we have 1 minus, well, the tangent of pi over 6, that's that yellow value. And the tangent of 2 pi over 3 is that green value. We're going to multiply those together. So we're going to multiply 1 over the square root of 3 times negative square root of 3 over 1. So I've got 1 over the square root of 3 minus the square root of 3 over 1. You know, I'm getting nowhere with that one. Let us clear the fraction. Actually, before we clear the fraction, I kind of liked what I was doing there. Equals 1 over the square root of 3 minus the square root of 3 over 1. We'll make it that much simple. 1 plus, because a negative times a negative is a positive, 1 plus 1, which is 2, right? So I need to multiply the numerator by the square root of 3, and I need to multiply the denominator by the square root of 3 to clear that complex fraction. So when I multiply that square root of 3, I get a 1 minus the square root of 3 times the square root of 3 is 3. All over, this is 2 times the square root of 3. And we know that that's negative 2 over 2 times the square root of 3. The 2's cancel out, and we get negative 1 over the square root of 3, which is what I thought the answer was, because pi over 6 plus 2 pi over 3 should be 5 pi over 6. Should be 5 pi over 6. And the tangent of 5 pi over 6 is negative 1 over the square root of 3. So that kind of proves for you that, yes, this formula does work, because we would get the same answer either way. But you can see here, number 3, we're going to need to find the sine of 15 degrees, the cosine of 15 degrees, and the tangent of 15 degrees. If you go around your unit circle, we've got 0, and then we go to 30, and then 45 degrees. There is no 15 degrees on the unit circle. Therefore, we can't just find the sine of 15 degrees without using a calculator. But we can